we're going to talk about life expectancy and then how the math goes with that life expectancy. So first we've got a graph here, and it's important that you really understand what this graph means. So at birth, this line here is at birth. So when you are born in each of these years, this is how long you can expect to live. Okay. Age 20, so age 20 then is the next line, the squares, meaning if you live to age 20, then, so in 1900, if you made it to 20, you would expect to live roughly 62 years. That's what this means. So each graph, or each line on this graph, it represents one of these areas. So number one, compare the life expectancy at birth for 1900, which is here, and 1998, which is here. Why might there be such a difference? Well, in 1900, it was roughly, I don't know, I estimated to be about 48. And in 1998, I estimated up here to be around 76. That is a difference of 28 years. So when you were born in 1900, you would expect to live to be 48. You're born in 1998, you can expect to live 28 years later just by being born 100 years later. And why might there be a difference? Medical advances. Think about 1900. There were not hospitals on every corners and, you know, cars everywhere and ambulances and all of that fun stuff, right? The world has changed dramatically since 1900. And, you know, if you had a preemie baby in 1900, the chance of survival was very low. Whereas now, you have a preemie baby and your chance of survival is very good. So just so much has changed. Less diseases, we have vaccines now. There's so many other things that have gone on between 1900 and, you know, we call 1998 now. That was 20 years ago. So even today in 2018, there's so many other things that would make you live perhaps longer. So has life expectancy changed much for individuals at age 60? Well, age 60 is this bar up here, so it was roughly 75 in 1900, and up here we're closer to 80 in 1998. So that's, you know, an increase of 5 years. Is that much? I think 5 years is a long time if you're talking about being alive or being dead. So yeah. And what is that reason? I don't know. Better healthcare, I think, is probably the main thing. You know, we have so much more now to help you live longer, and we know more. We're more knowledgeable about what causes good health and bad health and all of that business. Number three, why has life expectancy at age 20 so much higher than life expectancy at birth in 1900? So now we're comparing birth, which we said earlier was like roughly 48, and at age 20, which is, I'm going to say 62. Why is it so much different? Well, this is just me speculating, but if you think about it, in 1900, when the world was different, we had a lot more childhood disease, we had less medical care, so when you were young, you were more susceptible to disease, illness, you know, you could die from the flu so much easier, not that it doesn't happen now, but it was more prevalent back then. So if you made it to 20, in 1900, you were past most of those childhood illnesses and diseases, and therefore you tended to live a little longer. Is the difference in life expectancy between birth and age 20 any different now? When we say now, we're talking 1998, and they're right here. So maybe 1 year difference, maybe 1 year. I don't know. They're pretty close. Because now with all of our, you know, our vaccines, our medical hospitals, you know, I drive an hour to work and I pass 3 hospitals. So it's crazy to think that at any point in time, if you're ill, you have medical care close by in some respect. So whether you're born a preemie or something else, your chances of survival are just as good when you're being born as if you make it to 20. And now let's talk about the math behind life expectancy. So we're going to talk about 3 things moving forward, not only in this video, but in future videos, and that's the mean, median, and the mode. So when you talk about the mean is when you add everything up, and there are definitions here, but I'm going to kind of give you my own kind of maybe brought down. So the mean is when you add all of them together and you divide by the total number. Okay, so the mean is also known as the average. The median is when we put them in order, low to high, and then we find the middle number. So you can remember that because middle and median both have a D in it. This is also called the 50th percentile because it's directly in the middle. And then we have the mode. The mode occurs the most often. And so you can remember that because mode and most both have an O in them. So just a couple tricks of the trade. All right, so we have 10 people here. And so when we find life expectancy at birth, we take the age of a number of people of the age of when they died, and we find the average or the mean, and that's the life expectancy. So here we have the ages of 10 people when they died. It doesn't matter, we don't discriminate, just 10 people when they died. And if we find this average, we will find the mean or the life expectancy at birth. So remember, to find the mean, we're going to add all of these together. So if I add them all up, and I'm going to erase that because I'm going to need that later. If I add all of those together, I get 377. There are 10 numbers total, so I divide by 10. So my mean is 37.7. So the average age at death was 37.7. The median. The median is found by finding the middle number when your numbers are in order, least to greatest. And you can see my numbers are already order, least to greatest. So we want to find the middle number. So I'm going to cross out a low and a high, right? Because I'm working my way to the... I keep pausing this for some reason. Okay, so I'm working my way to the middle, and you will notice in this particular problem I have two numbers in the middle. So I need to find the average of those two numbers because our median is going to be directly between them. So if I add 34 and 46 together, I get 80, and there are two of them. So my median is 40. So how does the mean compare to the median? The mean is less than the median. That is how they compare. And you can see the median is 2.3 less than the median. Okay, so we talked on that last graph, life expectancy at age 20. Well, that means we just look at only the people who live to be 20. So if we look at those who live to be 20, we only have 7 numbers: 22, 34, 46, 55, 58, 63, and 76. So if I add these 7 numbers together, I get 354, and I divide by 7. Now, this should go up from our original mean, because if you think about it, we got rid of the super low numbers. The 4-year-old, the 7-year-old, and 12-year-old, who are super young, at death, they're no longer part of this calculation. So my average will naturally go up. And number 5, when I go to the calculate the average age at death for those who survived to 60, well, now we only care about who survived to 60. That's just these two. So if I take the average of those two, first I add them together, I get 139. I divide by 2. That average is 69.5. So if you make it to 60, your average length of life is 69.5. So what would this be called? Well, this last piece here would be called the life expectancy at 60. Right? Similar to the life expectancy at age 20. If you're talking just till 60, then it's till 60. Okay, now there was an error. The oldest age at death should have been 84 instead of 76. So how does that change things? Well, again, to find the mean, we're going to add all of these numbers up and then divide by 10. So when I add them all up, it went up slightly because we had an 84 instead of a 76. We're still dividing by 10. So the mean increased just slightly because one of the numbers increased just slightly. When we're finding the median, you can probably already guess what's going to happen, but I work my way in just like I did before. That's supposed to be a 22. I still have these two numbers. The median hasn't changed. It's still 80 divided by 2, which is 40. So when a number changes, your mean is affected. So our mean increased, but because the 84 was on the outside and it wasn't one of the middle numbers, our median stayed the same. Now you can imagine if 34 or 46 had changed, then our median would have been impacted. But because the number that changed was way out here, and it's one of the numbers that gets kind of crossed off in the median process, then it doesn't change the median. It only affects the mean.